So this is example 4 in our series on maxima and minima. So I'm just going to go through this one, and then I've got another one that's I've made up myself for you. And these will give you a good flavour of how to do the more complicated ones. So what we've got in this one is that it's a more realistic example. We've got the voltage in a circuit is given by that function there. So again, it's a cubic, and R is the resistance in kiloohms. By the way, that MV means millivolts. Obtain the values of R, which make V a max or a min, and calculate these values of V. So this is more electrical engineering example. So let's just go and solve it now. You should know how to solve it. So the maximum and minimum values, the turning points, occur when the derivative is equal to 0. So we differentiate this guy. So we've got that as the voltage. If you differentiate it, it becomes 9R squared minus 270R plus 1800. And then we set that equal to 0 because we're looking for the level points, the horizontal points, for the maximum and min. Now, the author has noticed that you can take a 9 out of there. So if you take a 9 out, a factor, then you're left with R squared minus 30R plus 200. And if we set that equal to 0, one way you can do that is to factorise it. And if you factorise it, it becomes R minus 10, R minus 20. Some people are able to do that instantly. Other people really struggle with that. So if you can do it, fair enough. If you can't, it's no problem. So, either R is 10 or R is 20. So either the resistance has got to be 10 kiloohms or 20 kiloohms. One of the two. But what if you didn't see that though? What if you struggled to do that? Then what you can do is that you can take your 9R squared minus 270R plus 1800, which is that, and you can just solve it using the quadratic formula. So there's the steps. So the roots would be negative b plus or minus the square root b squared minus 4ac all over 2a. A would be 9, b would be negative 270, and c would be 1800. So big numbers. But if you put the numbers in, actually it becomes okay. Eventually, if you work it through, you get that R is 270 plus or minus 90 over 18, which is 270 minus 90 over 18, and the other solution is 270 plus 90, all over 18. And that works out as R is 10 or R is 20, just the same as before. So if you get stuck with the factorization, it's okay. You can always just use the quadratic formula. Quadratic formula is good and is used an awful lot in further engineering. Don't feel bad if you have to use the quadratic formula. So I always say to classes when I was at Glasgow, one of the things that we were doing was that we were continually using the quadratic formula to investigate the stability of satellite pointing systems. So, it's great actually to get used to it. So to find the nature, we have to differentiate again. So that was the first derivative. If you differentiate again, you get 18R take away 270. And we just plug our two values in of R to find out if they're positive or negative. So if R is 10, then 18R take away 270 becomes negative 90. So that's a maximum. And if R is 20, d2v by dr squared, the second derivative, becomes plus 90. Just putting a 20 in there, becomes plus 90. So that's positive, which means that that is going to be a minimum. So what we've got is that we've got a maximum turning point at R is 10 and a minimum turning point at R is 20. Now, the only thing we need to do then, just to finish it off, is to find the actual values. To find the values, you just plug them in here. So remember, we're going back to our original function here. So at R is 10, V is going to be given by that. That's right at the start of the question. It tells you how to find V. And if you put 10 in, you get 7,700 millivolts. The electrical engineers will say, well, that's 7.7 volts. Yeah, that's true. But we'll just have it as 7,700 millivolts. And if R is 20, again, we just plug it in here to find V. And once you work through it, it becomes 6.2 volts, 6,200 millivolts. So you've got a maximum voltage of 7.7 volts, 7,700 millivolts when R is 10 kiloohms, and a minimum voltage of 6,200 millivolts, 6.2 volts, when R is 20 kiloohms. So hopefully that helped you, that made sense, and we'll do one more, and then that will close this series out. You should be able, after we've done that, to do all of the examples on worksheet 13. So, thank you very much.